dear to my heart because this is what I do for a living, is technology in architecture, construction, and engineering. We're actually going to be watching a video that was produced by an ACE group down in Florida. It's part of the ACE at Home materials. And then at the same time, I have, a bunch of software open in the background here. So afterwards, if we do want to do any kind of deeper dives into those specific pieces, we can do that. And then the activity for today is we really need to start thinking about our projects in 3D. Some of you may have already, some may have not. So there's lots of different ways to do that. The activity that we do have a video for is drawing a 1-point perspective. So have any of you drawn in perspective before? We're kind of thinking about what it would look like if you were standing actually looking at the building. So thinking in 3D. There's other options. Obviously, we're talking about technology today for those of you that are interested in doing some computer modeling. I know some of you are taking drafting classes and do have access to AutoCAD or Revit, SketchUp. Some of you that have been in ACE before may have some familiarity with that. So there's all sorts of programs out there that you can use. And then also just thinking about if you're struggling with drawing, just doing, like I think I mentioned before, tiny little models to think about what the form of your building is. As we continue to kind of develop these designs, we want to make sure that you're all considering, kind of the big ideas behind this project. So we gave you, a limitation of 28 feet by 8 feet, but remember, you don't have to build a box. I know a lot of precedent images I saw had different, maybe a porch sloping, or a sloped roof, or part of it goes up, part of it goes down. Like there's all sorts of things you can do. So I think we want to start thinking about that and think about the exterior of the building too, and I know you guys have done some really good floor plan layouts, so think more about how that might work with the outside. So this is all tied together. So just our weekly reminders, check updates in your small groups classroom. Biggest reminder right now is scholarships are going to be sent out soon. So every year we award scholarships, monetary scholarships to seniors and scholarships to underclassmen for NC State's design camp and engineering camp. So all the information should now be posted in your Google Classroom. Those scholarships will be going live on December 15th. So as in previous years, it's all accessed through the acementor.org website where you'll log in with your student profile. The application will be available on the 15th. You'll fill out some basic information about yourself. We'll have essay questions, and that's the application. We obviously this year things are a little different since we're not meeting in person, but we're really going to be looking at your participation, so your attendance at both large and small group sessions. If you've been submitting activities, if you've been participating either in chat or asking questions on either large group or small group, in addition to your essays. So all of that will go into consideration when we are determining scholarship recipients. And those scholarship recipients will be announced at our final kind of end of year ceremony in March. So keep that in mind. The applications will be open for a month. So you have some time over the holidays to think about these essay questions that we're kind of putting the finishing touches on right now. Your lead mentors will notify you when all that's out. And like I said, it'll all be accessed through your student profile on ACE.
Also, Laura, would you mention about they need to be active and they may need to present some more documentation to us?
Yes, so if you know that you don't have your parental consent form signed and uploaded in your registration, you need to do that in order to be able to even apply for the scholarship. So please go ahead and make sure that you have that. If you're not sure, you can go in and check. And last resort, your lead mentor will be contacting you if that needs to be done. The scholarship application can't be accessed without that parental consent form. Okay. Anything else, Bill? Okay. So like I said, today we're going to go ahead and take a look at a video on architecture, engineering, and construction technology. I'm just going to launch kind of a few polls while I get this video set up here. So I guess I said, this was near and dear to my heart. So I am a virtual design and construction coordinator. So a lot of the technology that we'll be watching in this video is what I do on a day-to-day basis. Like I said, I do have a lot of software open up in the background here. So if you do have any questions, obviously as we're watching the video, go ahead and post them in the chat, and then we can kind of take a deeper look if we want to when that wraps up. So I'm going to go ahead and switch here to this video.
Hey there from sunny Central Florida, ACE Mentor. We're excited to share our virtual design and construction engineering technology, ACE at Home. I am Travis Kolbjornsen, Chairman for the ACE Mentor of Central Florida program, as well as Business Development Manager with Barton Mallow Builders. Today we have a trifecta of talent that includes Adele Shalaby from Rhodes and Brito Architects, Lee Slay with Barton Mallow Builders, and Andre Tousignant with PCL Construction. And also with our team is Nick Pepe. He's actually the mentor leader for South Orlando and been leading a big group of kids down there. He's going to talk a little bit through the homework tutorial and what you'll use as kind of a practice of what you've learned today. They're going to show you a little bit about how they utilize these tools that support the ways we move through the design and construction industry.
Thank you, Travis. So my name is Adele Shalaby. I'm an architect. I have about 20 years of experience in the architectural field. I will be going through the design process and how we utilize this technology that I'm going to mention today. This is an example of a project that we've worked on. This is in Heritage Park outside the Orange County Regional Center. The task from the county was to try to figure out what's the best way to provide some more curb appeal to the building, and given that the existing location had so many trees in it. So what we decided to do is to scan this location, all the trees and everything out there, to try to figure out what the existing conditions are before we investigate what the proposed designs are going to be. So this is a quick video showing the point cloud, which is, in other words, the way that a camera can scan the space, and it provides you the data that is in that space. So all these little dots, it's information that is collected all over by the 3D cameras that are placed there. And if you see, you can zoom in and actually see the space in 3D. I'm going to spin through it a little bit. You see those little orbs that are located in the middle. Those are actually where the camera are located. And if you click on them, you can actually see some of the shots that are there in that location. So we took that information, that digital scan, and we converted that into a conceptual design that allowed us to come up with different ideas. We took that information after that, and we provided a SketchUp model, taking the 3D data that was provided from the scan, and we developed a conceptual design that we were able to use. I'm just going to play on it. So this is actually a scan of the existing conditions. We were able to model it, all the trees, what was there, what was the existing conditions. We started trimming some of the trees out to improve visibility, so we were able to see the building in a better way. We were able to get different shots. We provided some design options for the client to better understand how they can utilize this space. And this is some cool ways to look at your design in different daylighting conditions. So this slide shows, the top picture shows the existing conditions. The bottom one shows a day shot, and it was rendered in SketchUp, rendered and put in a filter that shows it like watercolor. Seeing what we've done once we've reduced some of the trees, allowing visibility to the building, and it gives you a different look of what the building is going to look like. And this is a different shot, the night shot. We provided 2 bus stops at that location. This is another day shot for the existing conditions. This is what we were able to do by reducing some of the trees and providing a new entry feature and signage that was put at the edge here. And this is kind of a night shot for it. And we provided some sculptures, again, give them ideas of what they can utilize the space, see all the trees that were there, and we were able to utilize the scanning technology and the information we provided in the proposed concepts using SketchUp to give the client a better understanding of the space. The other sample I'm going to show you is from the convention center. The task here, and this was an actual picture from the space, the task here was to enclose the space above and create office space. So It's very hard to try to measure this by hand and try to figure out what's going on. So what we decided to do, we took a scan of the space. So this is an actual scan of the space, a 3D scan of the space, utilizing a Leica camera 3D scanner. And we provided storefront glass in here to enclose this, and that becomes the new office space above. So this is a scan. We have multiple scans, and this is using a program called Recap. It takes the digital data that we provided from the scan, and it stitches it together so you are able to actually go into the building and visualize everything there. You'll see that you're able to actually take dimensions to verify dimensions, and this is the orbs that I was talking about. If you click on one of those orbs, it actually takes you to the 3D picture that was taken in that space. And you can see along the line here, we've got number of camera shots that you are able to take and do it to a 3D view. So if you look at all these little orbs that are here, this is different locations that we took the scan. You are able to have superpowers or get into the walls once you transform into the point cloud and are able to see everything in there. The importance of these dimensions, they help us to measure the existing conditions live. I don't have to keep going back and forth the space to do this. I'm able to do it remotely when I'm in the model. Then I could take this information and prepare a computer model for it. In this project, we decided to utilize Revit because the intent was to provide construction document, not just conceptual drawings. So what we ended up doing, utilizing the scan, and here you see that at the bottom, you're playing with the existing conditions. You can turn on different filters, so you can see this is the existing building, and we start adding the phases of the work so we can phase what we are trying to present to the client. It gives them a better understanding of what they have, what they expect to the final product, and build the project in the virtual world before it goes to construction. This gives you a whole lot of different ideas of what you can do. Going through these shots, it shows you a 3D camera of what you can be looking at. You could render this. You could cut sections. So again, it allows different levels of flexibility for you to show this to your clients and the end users when they're understanding the project.
My name is Lee Slay. I'm with Barton Mallow. I'm a VDC engineer too. I have 4 years of experience in the construction industry, and my background is in design and architecture for my bachelor's and construction management for my master's. And I'm going to be talking about constructability reviews and a couple of different ways that they can be done. What is a model constructability review? So this is meant to complement traditional constructability reviews, which are typically done in 2D. So typically our estimators, our planners will look at a drawing in 2 dimensions on a PDF or just flat on a computer screen or print it out and go through and see if there's anything that stands out, that doesn't quite look right. They'll make notes by hand, things like that. So constructability reviews in 3D are completely different. They look at the design from a different perspective, like you're in the space. It's a unique tool to help prevent future RFIs or cost change orders. And we're essentially looking for issues that can be designed out rather than worked around when we're in the middle of construction. So we're trying to get ahead of all of the problems that could possibly come up, especially really big issues that we're not seeing until it's too late. So in general, a comprehensive review of all of the systems together. And then on this next slide, here's just a quick example of an image. This is a screenshot from a program called Navisworks. This is a 3D coordination review program. So it takes all kinds of 3D model files and puts them together so that everyone's systems can be reviewed in a 3D space. So here you can see that some of the plumbing pipes are going through the steel beams. They're running through the building and hitting in multiple locations. And we use programs like these to keep track of these problems early on, address them with our design teams, and get ahead of them before we're in the field and trying to come up with a solution when we're on crunch time and we have to get this project done, and now there's a pipe in the middle of a beam, and what are we going to do? So there's a couple of different programs that can be used for constructability reviews. On the left side, this is a web-based application called BIMTrack, and it's an app that plugs into Navisworks, which I just showed you earlier. And this program essentially takes viewpoints from Navisworks where clashes or points of congestion, areas that are conflicting, have been saved in the program. So essentially little pictures, and they're exported to BIMTrack, and a record is kept in BIMTrack. And you can see there's a summary that it keeps, and it's all color coded. So blue means it's a low priority clash, and then it goes all the way to red, which is a high priority clash or problem. And it keeps track of this versus how long it's been active, if it's been resolved, how many issues there were on that particular day or week. And usually over time, the issues may increase, and then once the trades and the team starts working on these issues, they begin to decrease. So the colors will change accordingly as coordination goes on. On the right side is an example of the clash detective from Navisworks. So this is a part of the program where you can tell the program, hey, I want to see if there are any problems with the mechanical ducts and the plumbing pipes. And it will find those systems. It will do essentially a 3D scan of the model in 3D space and see if those two systems are hitting each other, if they're touching or if they're within a certain amount of space within the building, and it'll mark it as a conflict or a clash. And it allows us to review those later on and present them to the design team, to our trades, and so we can work through them ahead of time. The other option that we have for 3D constructability review is laser scanning, which you saw some examples of that earlier on. And what we have here is an example of a medical center renovation. This is Holmes Regional. It is a 30,000 square foot renovation project, and we laser scanned the entire floor. So there were actually about 20 scan locations, and you can see here a couple of different pictures from recap over here in the bottom right corner, and above is more of a specific space, and then on the left side it's the panorama view of that space kind of stretched out before it's been folded or wrapped around so that you could see it more of in the way that you would see it if you were standing there physically. So when we did this project, we noticed when we went out to laser scan, because it's easier to tell the current conditions for a renovation if you scan instead of having someone run around with a measuring tape and sticks and paper trying to keep track of all the measurements and where everything is. It's obviously easier to laser scan. So what we found out was there was a 2-foot discrepancy between the existing structure and the drawings that we had. And you can see these from the little markups, the little circles. There's some pretty big changes there. So we were able to determine that the design models and drawings were off from the reality. So this allowed the design team to adjust their drawings before we went into construction, after the field verified all this data. So that saved a lot of time, saved a lot of money on the front end of this project, and a lot of heartache for the design team and the construction team. The other version of constructability reviews, we can also do this with drones. And this is always a cool, fun way to get out on site, talk to the team, and how everything is progressing. The great thing about drones is that they provide so much information in just an image. They're able to provide terrain model data. You can overlay images, so you can get a PDF drawing of your current project and overlay it on top of the pictures that the drone has taken, and it'll help locate utilities. Is quality control for active construction. You can see, okay, this is where we're at, this is where we should be, is this footing in the right place, here's the future location of an elevator pit, here's some utilities, things like that. So it helps us get ahead of any potential problems that may happen in case we are noticing that maybe things aren't being installed in quite the right spot, or if we're seeing utilities underground that maybe weren't taken into account during the design process, or we're in a slightly different location than expected. So this helps save time and money on the front end as well. When the time comes to build the building out of the ground and start putting up walls, we know where everything is. Everything has been accounted for ahead of time so that there are no surprises.
I'm Andre Tusingat. I'm the virtual construction manager for PCL in Orlando. I've been working in construction here for 15 years, and my background is actually in civil engineering. I have a bachelor's degree in civil engineering from the University of Florida. So let's talk about how we can use some of these 3D models and some of these other technologies during construction. So one of the first things that we'll do is go through a very detailed 3D coordination process. So the steel manufacturer, all of our mechanical, electrical, plumbing trades will take all of those design models and, they'll kind of plus them up to really take them to almost a fabrication level that they can ultimately use to build the structure. So what we then do is we take all of those parts and pieces and put them together to actually coordinate all of the space, even further before we actually start building the structure itself. So next slide here, this is just a couple snippets from Navisworks as well, where again, we're building everything virtually before we actually put the real thing together. So in a commercial space, such as this example of a large restaurant area in a hotel, we may include a lot of lighting fixtures or even furniture, so that we can go ahead and we can determine the final location of, say, specific items inside of a ceiling so that we can maintain, sort of the design intent that was meant. So you may not think about it when you're looking up at a ceiling, but a lot of times there's a lot of thought given to where those fixtures need to sit in relation so that everything is symmetrical along with all of your HVAC ducts and everything along those lines. So the next thing that we will also do, especially when we get into building, is we will take a lot of those design models as well and we'll turn them into actual plans that we can further detail out to build with in the field. So inside of Revit, again, you notice a lot of the same software, a lot of the same technology being used through all phases of a job here. We're taking this really complex couple levels of this tower structure where you have a parking ramp going in, you have a number of pieces of interfacing with each other, and we're kind of creating just a very simple color coordinated construction sequence just to be able to better show the order of how things are going to go together. And then what we'll do from there is, we'll take this overall view and we'll split it up into each individual piece. And we'll show all of the additional details, information that we need to actually build this out in the field. Now, on the next slide here, we have a similar situation. We have a 3D model of, this top of a tower. But sometimes digital is great, but sometimes it's not nearly as good as actually having something physical that's in your hand. So believe it or not, yes, we even as contractors, we still will 3D print objects, especially here. This particular top of the tower was really trying to get everyone a very good understanding of how the pieces all actually had to fit together and what it would look like when it's done. And the picture doesn't really do it justice. This model is probably about 2 feet square, and you could take each level off. So even though all of this, the digital models are great, just having something physical is really still beneficial for a construction team. The next example here, this is a bridge job that we had down in South Florida, and we had a lot of existing field conditions that we had to work through. So just like we had laser scans done during the design and pre-construction process, here we did laser scanning so that we could actually as-built this dock that's on the left side of the image. And the whole reason we had to do that is we had a couple very large barges with cranes as well that we had to fit into a fairly small area. And the last thing we wanted to do is move any of these barges into position, especially around some of these very expensive boats that we had nearby. So this is a case where, again, we took that design model, we added some more information to it. We've put some crane models and some of the other parts and pieces in there so that we can physically plan everything out before we actually get into building it. Then we take this model, and on the next page here, now we've actually turned it into a full work plan where we've got all of the particular details, the exact sequence, all the kind of things that you would need to be able to actually perform this lift out in the field. And on the next slide, this is an aerial image of that exact work actually happening. So you see, we've really come full circle here, not only with the technology, but just with the 3D models in terms of making things, real. Now, another thing that we can actually do with the models is we can actually use that to lay out the structures in the field. So unlike just a traditional surveying, which a lot of times they would be dealing with maybe just specific points, we can actually push those models into some of the software, some of the surveying equipment that we have, and that model will basically generate all of the points that we need to lay out a structure. So the example on the left here, this is a curved wall that has some varying elevations to it. And you see each one of those gray dots is actually a survey point that we can go stake to and lay out. So rather than manually calculating all of this information, we're letting the model do all of that for us. Very similar example on the right, where this is just what seems like a very simple curb layout for a parking structure. But to go out and lay that out traditionally would take a lot more time versus here, we push the model out into the field and we can quickly generate all of these points, all the information we need to go ahead and lay it out and successfully build it. Now, what do we do once we've actually built it, right? We still have to verify that what we've built is correct. So that's what on the next slide here. Again, using a lot of the same technology here, we're using laser scans to actually verify what is built matches the tolerances of what we're allowed to build. So in this case, this is a bridge structure about 100 feet wide, about 90 feet in the air. And all of the concrete formwork that's supporting this, right, believe it or not, when you pour concrete into formwork, that formwork does move. Now, mind you, it may only be fractions of an inch, but in some projects, you can have very tight tolerances where fractions of an inch really add up and matter. So in this case, to actually verify that this really large structure was still within the allowable tolerances, what we did is we went out and laser scanned it and compared it to the model. And that's what you see here is the varying colors are representing how far from the design the certain areas are. So we could very quickly verify that all of the formwork and everything was moving and setting just the exact way that the computers predicted that it would. The next slide here, again, Lise mentioned earlier using drones for verifying progress, right? And of course, we're definitely going to continue to do that through construction. So it's important to note, that when drones are flown in a lot of AEC projects, right, we're not just generating just simple photos or just simple videos. As mentioned before, we're actually generating models from all of these photos. So in the example here, you see on the left, this is the actual color image. And on the right, that's the actual 3D model that was generated from that drone flight and all of those images. And this exact same technology is used in a lot of other industries as well. A lot of video game companies will actually use this. So if they have to model an existing building or an area, they can do it a lot quicker this way than they could traditionally. And we're even seeing films nowadays where, same thing, they need a model of a certain structure and they can use this to get that information a heck of a lot faster. So the next slide here, this is an example of where we've used that drone data. We've overlaid it with the design, and we're using it to verify that some of these curved walls on this hotel job are actually in the right space. So yeah, we could go out and we could use traditional survey, and sometimes you still need to, but in the case here, we can capture a lot of information very rapidly and compare a lot of design information very rapidly as well. with that, that's all we have on construction.
Nick Pepe here, speaking from PCL. Wanted to bring everything into a close. We've seen some presentations from the architecture, the design side of life. We've seen some presentations for the pre-construction and how to deal with different class detection. We've also seen from the construction side of life where you can use drones to fly and get real-life modeling. Now, something I did want to point out to the students is the fact that we have 3 different professionals with 3 different degrees, all using very similar programs. They're all using Revit, they're all using Navisworks, they're all using drones. So they all have very different backgrounds, but they're all coming together to use this new and advanced technology in very different ways to solve real life problems in our industry.
Okay, we're gonna skip that part and actually show you guys the video later if we have time, but it looks like we had a lot of conversation going here about modeling, drones. So I think what they said at the end there was an important point about, you know, everyone in the industry is using this. So all of the mentors on this call have probably used at least one piece of technology that was talked about in that presentation. So I think I neglected to mention, like I said, what I do now. I'm a virtual design and construction coordinator for Clancy & Thay's construction company, but I myself have a degree in architecture, and I actually worked in architecture for about 13 years. Cody Whitelock, who is another mentor, probably here on the call too, he has the same position as me with Barnhill, but he has a degree in civil engineering. So there's lots of different ways to get into this, and every, you know, technology is everywhere right now. And actually, is Cody with us? Because Cody is a drone pilot and might be able to answer some of these drone questions better than me. So he is. Are you able to talk? If not, just go ahead and maybe answer some of those drone. He's probably on the road, or hopefully not because he's typing. We'll say he's in another meeting. We'll kind of save those questions for Cody. He can answer those a lot more intelligently than I can. Kind of set out a poll here to see what everyone was, you know, what piece of that you found most interesting. Is there anything that wasn't covered, or any of the mentors out there, any other pieces of technology that you think would be interesting to kind of take a look at with these students? While y'all are thinking, I'm going to dive in and I'm going to show when Beckett asked about any COVID considerations. I said one of the things that we are doing now is some virtual walkthroughs. So for those of you that were at our field trip last year, you probably remember we went and looked at the office building that was under construction. So here it is today. It's still in progress, but almost finished. What the platform I'm in here is open space. So those of you that are in the orange small group, this is what Kendall and Carly showed in their office tour presentation, this same software. But what's really cool is what we see here on the left is the state of the project actually yesterday. So it's obviously still under construction. And what you see on the right here is the model. So this was a model, you know, I think the presenter mentioned how there's lots of different models combined together. So really what we're seeing here is mostly the model from the architect, but this was the model on the right that I worked on during the coordination for the project. So I think I spent, I know there's a question about like time in the chat there. So I think when we did just straight model coordination, spatial coordination, I want to say we maybe took like 4 months on it. But there's all sorts of other efforts that go into it. So what's really cool about this is I can spin, and it, obviously we don't see this existing building over here, but I can spin and I can really see what's going on with the project. So I thought those of you that, like I said, that went to the field trip last year might like to see what it looks like now. But not only we can go outside, we can also go in the building. So I can come in here, I can look at this lobby space. It actually has AI now to blur out people. which sometimes works, sometimes doesn't, but I can come here and I can kind of, like I said, virtually walk through the building. So here I'm comparing it to the model. What I can also do is I can also compare it to different points in time. So if I want to see, if I maybe want to see, you know, what it looked like before drywall was installed, I can go ahead and do that. Here's what it looks like up on the 9th floor, kind of looking out over Raleigh. Same thing, we've got the model on the left here, or the image on the left here, and the model on the right. So that's one way that we can do virtual walkthroughs, trying to kind of get into it. So a couple questions I see here. So if I pull up, I'm actually going to pull up Navisworks now. So the presenter also talked about this. Go ahead and just share that. Let's do my entire screen. Okay, so this is Navisworks. So this was the model that I was working in. So this was showing like how we're looking at clash detection, which you mentioned, where we can see, this is actually pretty good here, but it looks like maybe we've got a plumbing pipe hitting, I'm not sure, fireproofing around steel maybe. But if I come back, so this is the model that I was working in for 4 months, Beckett. So I personally didn't do any modeling. So all of the modeling was being done. So what you see here in pink is electrical. So we see conduit here. For those of you that have been with us a while, you probably know what conduit is. We see lighting, we see clearances around lighting. Green is duct, and generally green is duct, and blue is plumbing. And this is a model from back in June. So what I was doing is I was running coordination meetings once a week to kind of come through here and see where all these different kind of clashes might occur. I actually, just before I got onto this meeting, I was doing a presentation for the AIA, and we were talking about, there was a really tight ceiling space here, so we spent a lot of time really just looking at how we would fit everything above the ceiling and below steel beams. Okay. Yes, Selena, the pool is done at the Peace Project. I believe people have moved in. So that is Navisworks. Question? I heard a voice.
Oh, no, it's Cody.
Oh, Cody, perfectly. Perfect. Do you want to kind of, we had a couple questions about the accuracy of drones and how that's been developing. I thought I'd let you handle that.
Let me share my screen. So drones, they're getting a lot better over time. They're starting to be used in a lot of different applications. One of the things that, like Laura had said during her presentation is there's a lot of new technology. So let me see, which screen am I sharing here? Here. Sure I get the right one. So what you should be seeing on the screen now is the project that we're doing out in Morganton. And it's, if anybody knows where Morganton is, it's on the western part of the state. So there's a lot of mountainous and hilly areas out that way. And we're building a new school campus out that way. And this is an orthomosaic that's been done, which is a big, gigantic picture of many, many pictures taken of the project using a drone. And over time, what we can do is we could take those pictures and we can do analysis of where utilities are being located, which is what all these lines are. And you can turn some of these on and off. We can determine, square footages. We can do volumetrics, determine how much dirt is in piles. But we can also do some comparisons over time. So I can do 2 different dates in time, and we can compare them together.
Yeah.
Cool. Yeah, the comparisons that are coming out in a lot of different software platforms now are really cool. Just to be able to see changes, even when it comes to just models. You know, you can get a new model from a designer and then see what has changed.
And then Laura, you were saying that you did fireproofing on that Navisworks. I was asking a question there.
Yes.
Gotcha.
Yep, we modeled that. Bob asked a question here, is GPS used with drones?
Yes. One thing to note, though, the way that we do it with drones, that's very similar to a total station, but a little bit different. So we have benchmarks, which are just physical points on the ground that a surveyor has laid out. And then from that, the drone can geolocate those benchmark points to determine the geography of where this position is located on Earth. And then we can put it into a program to do that analysis. One of the things that's changing a lot with big acre sites like this, over 100 acres, is a lot of surveyors are starting to supplement this with what they're doing with total stations. But there's a lot of states and a lot of surveying groups that the accuracy of this for surveying is still ongoing. It's not as accurate as a total station, as a total station is done from the ground, as this is done from the air. So the higher you go, the less accurate it becomes. So it's one of those things. It's kind of a catch-22.
Looks like we've got a lot of interest in drones. So we have, and whoever the Nazareth is, your question. So like at our company, we have established drone pilots within the company, but we do sometimes hire out to a third party if we're really booked. So it can go either way.
I recommend you tell your parents that you need a drone for Christmas to further your education, and go ahead and get your pilot's license now.
Yeah. There is a lot that you can do. Okay. William, I'm not really sure. So are you talking about when you're building a model, like how big the actual model is? Are you talking physical
like,
or
okay,
digital?
so this model right here, right?
Mm-hmm.
Like, is that entire model the site, or is it like the site and places around it?
For the majority of it is just the site, but there is some, over here is not part of the site. So anywhere you see this fence line is part of the site.
Got it. Thank you.
But you can do, like, for instance, let me just go to another job that we're doing. The Tiger 6, which is this really, really large greenway project in Asheville. All this outside of here is all the existing conditions using GIS and Google Maps. Everything that's more colored is the actual drone footage. So you can have both, and you can overlay both together.
Yeah.
Thank you.
So Catherine's question here, how long does it take to make a drone model? So it's really just the flying is probably the shortest part. The processing that's going on behind the scenes to get to this point, the same with laser scanning. Like the actual physical going out there with your tripod and doing the laser scan, it isn't that long. The processing times are getting much faster, but there's, when in that presentation when they were talking about all those little points, it's a lot of points.
And Cody, for the flight itself, you can have the drone fly a predetermined path, correct?
Yeah, exactly. Yeah, that's exactly what I did. I had 6 different flight paths across this 2.5 mile greenway, and it takes pictures of what I want and how high I want. There's benchmarks that are placed throughout this whole 2-mile journey. And then, like Laura said, you put it into a program and it processes this together.
So I'm just going to show one. So we do have some questions about SketchUp. So let's talk a little bit about, because we obviously do want you all to start thinking about your projects in 3D. We'll be posting a lesson on actual drawing. Especially, I encourage everyone to watch it and actually draw. So like I said, we have to start thinking about these projects in 3D to draw a perspective of your building. Watch that. There's SketchUp, I believe, and someone correct me if it looks like John already responded, that there is a free version of SketchUp for students.
Yes.
For those of you involved in drafting classes, I'm not sure how they're doing it now, but they're also, Autodesk often offers free products for students. So that's another place to look. John, did you have any other suggestions?
No, I mean, SketchUp's a good one to use.
Yeah.
It's a little more intuitive and a little bit faster to pick up than some of the others, unless you're already taking drafting classes, in which case I say do what you're comfortable with already.
Yeah. And even just some really basic modeling. The Tinkercad is like a thing out there by Autodesk that's really just shapes. And for those of you that are just kind of want to think about the overall shape, that might be a good way. And I did see when I posted the question about computer modeling that some of you have already done computer modeling. So use, whatever works for you. And then if you don't, like John said, in architecture school, we're still drawing by hand. We're still doing, physical models. So there's all sorts of ways to start really thinking about this before so next week we're learning about interior design, and then we've got another small group session. So you have some time to think about, getting this up into 3D. I think it'll really start to make a difference on how you visualize this project.
So I have the SketchUp website pulled up. The free one currently is a web-based. So somebody asked how much space it takes up on your computer. It won't take up any unless you save your files. So everything is run through the web. So I'm thinking it runs pretty smoothly despite what your speed on your computer will be. So.
Yeah.
And any help as need with any of the softwares, me and Laura and most of us that are in the industry can help you out. If you're going to do Revit, if you're going to do SketchUp, one or the other, we're all here to help you. This is kind of the tougher portion of it, especially if you're just starting out with ACE.
And kind of this last thing I was going to show here was kind of combining, 2D and 3D. So in this program here, we talked a lot about models, but we're still using drawings. So this is one program, it's called Revisto, where we can actually overlay. So what we're looking at here is the structural engineer's foundation drawing that actually Lynch Mikens, so Taylor is with us from Lynch Mikens, that they produced, and then we can overlay it on top of the model. So same as before, what we're seeing here is all of our trade models in pink, so we can really see what we were looking for here. And I can kind of move this down and cut down further. We wanted to see where we might be conflicting with foundations, because further on down the line, we've got some plumbing running under. So it was really just a good way for us to do that. We can also overlay, we've been talking about all this drone data. So this is another office building that I am working on, where we can bring in that drone data, that point cloud data, 2D drawings, we can bring it all into the model here. So if I look here, and I can go ahead and, I did not have this pre-planned, but I can, here we go. So what I'm seeing here is the model is set to transparent, but then I actually have the point cloud from our drone over top of it. So we can really start to visualize how these things work, and it knows where it is in space because we've set coordinates. So, that gives us that advantage too. So here we're looking at these different concrete pours, looking at penetration. So here, like I said, is where we're actually putting the drawing on top of the model, on top of the point cloud. So it's combining, a lot of the stuff that we just talked about, where we're getting it all into one spot. So this is another really powerful tool that we use to just look at all this data. Because I'm sure a lot of you have kind of figured out as we've been talking, there's a lot of different sources of stuff out there right now. So we really have to figure out how to use this. And Taylor's right, that was West Millbrook Middle School. So I'm working on overhead coordination on that right now. That is my current task, among others. Looks like Zoo is bringing up SketchUp too. So like we said, there's so much out there right now that you all can take advantage of, even virtually.
Yeah, so SketchUp is the free software you guys can use over the web, and these are just examples of what other people have done. So the possibilities for SketchUp are endless. So don't feel like you're limited. I guess obviously you have to learn the tools of SketchUp, but once you do, you can create things like this. And also you can do sections and other things with the model once it's complete.
So I can talk about this for hours, but I just want to make sure I'm addressing any other interests that students might have or questions.
I have a question for the students. When I was I taught myself SketchUp. So you can do it too, first of all. I taught myself in school, but the way I taught myself was I watched just a bunch of videos on YouTube. And that 10 years ago is a great way to learn it. Would you guys still say that's a good way for the students to, if they've never done it, could they watch some videos online? Is that still sort of the best place to learn how?
I think so.
Yeah, there's so many options. You can get pretty specific on, I'm trying to draw a house, how to draw a house in SketchUp.
Yeah.
I mean,
and I think when we think about going into, because obviously part of what we're trying to talk about here is the associated careers. So just a lot of you already said you've done some 3D computer modeling. So just knowing the skill of building in 3D is helpful no matter what field you go into. Because once you get the concept of it, just software generally is pretty easy to learn. But if you understand the concepts behind it, it's even faster to learn. So things like SketchUp, Revit, you're going to be bouncing through all of these in your career.
I think some of my students had talked to me that, one of the tricky things as they were thinking about it was, oh my gosh, it's hard to visualize it all in 3D. Well, when you're on paper, that's why it's sort of a difficult thing. It is tricky when you're in paper and in 2D, but when you can use the computer as a tool in your design and help yourself visualize and sort of sculpt in 3D, which is really fun.
Another thing you can do too is kind of build a general blocky model and then print it out and draw over top of it. So if you're struggling with this exercise of drawing a perspective, I mean, we do this all the time in practice, is printing out from the computer and then drawing over top. So that's another way to kind of get some juices flowing on the 3D aspect of it.
I would say the other thing too, Laura, with the programs like SketchUp versus Revit, with SketchUp, it's a lot easier to do, sketches and lines and extrude it. I feel like when we get into programs like Revit, there's more industry knowledge that's needed because of how it's built.
Yeah.
And just to point out, it used to be a contractor to come on a job site and he'd have his hammer and a level and he'd start building stuff. Now, a superintendent comes on a job site, he's got a total station, and he's got a tablet, and he's probably the most computer savvy guy you've ever seen. He might be wearing blue jeans and have dirt on him, but the guys that are out there really know these systems inside and out. And no matter what you decide to do, what engineer, architect, contractor, you got to know all these systems. And, it's just the platform we all work in.
I would say don't worry too much about, I have to learn a specific program, because there are a lot out there. And let's say you went and go through school, it's possible there'd be a whole new program out there. But getting the gist of a program and starting to learn how they work in general, even when there's something new, that'll give you a leg up. You'll understand the basics.
It'll change by next week.
Yeah, it's always changing and evolving. So don't get bogged down in specifics. But SketchUp's a pretty approachable one.
Yeah.
And it's been here for a very long time. So that one is a good one to start with.
Hey, I just got to have a shout out to Justin's hat, man. I love that thing. That's awesome.
We like it when y'all show us yourselves on camera. It helps us get to know you better, especially once we get into this scholarship. You know, knowing who you are really does make a difference in terms of us giving you feedback.
Excuse me, which scholarship are we going into?
Oh, so we'll talk about it in a minute, Jaden. I'm just going to kind of wrap up here, and then we can, I'll do another recap of scholarships in case you missed the beginning.
Hey, I got to run, guys. Great
Thanks,
being
Reed.
here. My HVAC guys at the door.
Okay. So just to kind of wrap this up, you know, I think I've talked about this at every session, but I think it's a good point to continue to make. As you saw today, once again, we're all working together. So, you know, keeping that in mind, all these, you know, how we're working on a model, the architect's working on a model, then they give it to the contractor, but they're still, you know, working on it. So it's really about getting, you know, working together, understanding all these different systems. So reminder, next week, large group lesson again, talking about interior design with LS3P. All of the scholarship information will be posted in Google Classroom. So reminder, scholarships, ACE scholarships for seniors for money, underclassmen for NC State's Design Camp and Engineering Camp, all based on an application that is coming out in the middle of December. We will look at your participation, your attendance, your submission of activities. So I will go ahead and post the video for this activity for drawing a perspective. So like I said, our next small group session will be in 2 weeks after next week's large group lesson. So thank you all for joining us today. I do appreciate you taking all the time. We've had a lot of good you know, input in these sessions. I think it's been fun. We'd like to see you all here. And we will see you all again next week at 5. So thank you, everyone.